Alright, it's about time I showed a more complete GitHub tutorial. So what I have on screen here is GitHub Desktop, a program that you can download from GitHub that, well, it means you don't have to do stuff in the command line or through the website, which can be a lot easier. So first, let's look how I would add the Lingo repository if I didn't already have it. Obviously, I already have it. But let's go to add and add new repository. No, I don't want to. I want to clone repository, sorry. Cloning is the act of copying an existing repository on the internet to your machine. So create a new repository would create a new one on GitHub. Add existing repository would take one of the ones that I already have and add it to GitHub. I want to clone. So let's go, well, I already have it right here. Right here because I've already done the thing. So let's go to the URL here and Brenton Wild's Lingo. This is all the thing that you need. Now here, it's already making a local path for me. I'm going to call this fresh2 because I already tried this yesterday to make sure it works. And I'm going to click on clone. And I'll cut out the next part of this because it's just downloading Lingo. And we're back. The reason why you're seeing this on screen right now is because I opened up the Lingo, the new Lingo instance, new Lingo clone in Godot, and as a result, it made an update to project.godot, which is about DaveSign. I never actually submit changes to project.godot, so it needs to import stuff every time I make a new thing to the repository. There's a couple of reasons I do that, but don't really worry about it. So, if I click Fetch Origin here, that should now be updating my Godot from the repo. And if I hit Ctrl-Shift-F, this will bring up the folder in which it's making the change, Lingo Fresh2. It's just where I told it to make it. It's not updating any of the files in any of these other clones of Godot, some of which I should clean up because they're very much not useful anymore. Now, another way to see this, if you don't remember the key thing, is repository, show in Explorer. Same thing, opens up that window. So, now you need to know several different things about how Git works if we want to go more advanced. The first is push and pull commands, and in this case, fetch is synonymous with pull. It isn't always, but in this case, you are pulling files from the repository to update the ones on your machine. A push is the opposite when you want to send the files on your machine to update the files on someone else's machine. In the context of GitHub and GitHub Desktop, you are usually going to be pushing to the remote. The remote, note the use of air quotes there, is GitHub's server. So whenever you're pushing a backup onto GitHub's server. And whenever you're pulling, you're probably pulling from GitHub's server. But in particular, you'll be pulling from the repository and main, unless you go to one of these other branches here, or you create your own branch. So let's just create a new branch right quick, which I'm going to call tutorial branch. I don't want my change. Well, you know what? I'll bring my changes to main because this is a good one to make. So publish this branch to GitHub is now it's actually going to create this branch on GitHub. And now whenever I want to get all this stuff back in the future, I can just pull from this branch. So if I make some changes, if I go to a different branch, I can always go here to GitHub and I can get my tutorial branch back. And I can make a commit to this one. I'm not going to commit to main. So if I commit to this, let's just call it literal garbage because this is just demonstrating commits. So let's commit to tutorial branch, and now I have no local changes and push origin instead of fetch. So when I push origin, this is going to push the change I just made, updating project.godot, to my tutorial branch. What is a commit? A commit is basically a series of changes that are determined by a diff. Well, what is a diff? So let's go into my literal garbage and find out. This is a diff. It shows that I have modified. If I were to add something, it would show up as a plus. If I were to take something away, it would show as a minus. And it's going to show what those modifications are. In this case, green lines are lines that I've added. Red lines are ones that I've removed. whenever I edit something, say with davepanel.gd, it shows it as a removal of the old lines and an addition of the new lines. And in this way, it can provide a very quick numerical value here for the number of lines I've added versus the number of ones I've removed, which tells you something in gross about how impactful an update was, but it's not always the most useful. So, now that I have this literal garbage, I can also undo this commit. So I can revert changes in commit. This will create a new commit, which is just, it takes all the diffs that were in the previous commit, so project Arcado, that was not what I wanted to do, and it reverses all of them. Just poof, reverses all of them. Here I can also select a branch to compare, so I can compare this to more murder bug fixes. And in some cases, I am behind. So these are the ones that I have made in murder bug fixes. And all, these are bug fixes that didn't make it in because I only got on my ass about making these and making a pull request for these when I saw that Brenton was already merging stuff yesterday. So these will be in the next update. But if you want them for now, you can look at the branch more murder bug fixes, and you can actually pull all these for yourself. Just be aware that you will have to make unique all of these because the build of Lingo does not yet have these. And it'll show that I'm ahead on some, which is little garbage, and the revert of little garbage. So let's not look at that because that's not useful. So now that we're looking a bit into how versioning works, you have some notion of why GitHub might be useful to you even as an individual. So let's push to origin so that I can undo this reversion. So I can delete this. I had deletion. I guess I have to revert the revert. Reapply. Yep, there we go. So it's a bit silly. I'm not going to publish this branch. I'm just going to delete it. Normally you wouldn't immediately revert and then reapply, but you might do that sometimes when you're trying to find a bug. So let's say you make a change in your level at the very beginning. Maybe you implement some kind of complicated script for your entry. 50 hours in, as you're modifying the middle of the level, you start from the beginning again and notice that your advanced intro is totally fucked. If you were just doing this on your computer, and if you didn't save previous versions on your project, all you could do is throw up your hands and start trying to bug fix it from there. If you're on GitHub, and if you've been making regular commits, if you've actually been, as you make changes, let's make a change right now so you can see how that actually happens. So I have my thing open here. I'm going to reload, so Jesus, to make that. I'm going to make some nonsense change to this. I'm just going to delete a bunch of stuff here. Now this isn't even usable because it's expecting an indent block, but it'll still save it. And if I go back to GitHub Desktop, you'll now see that it stores this deletion here, and it has this changed file. Whenever I go into this folder on my computer and I change any of the files there, GitHub Desktop is going to pick those up as changed files in my clone of the repository and allow me to commit. So, again, literal garbage, more demonstration. You need to make a commit, you need to make a comment, or else GitHub won't even let you commit. So boom. Now I can push to origin, and you're realizing it's actually giving me an interesting option here, preview pull request. If I wanted to make changes to actual Godot, I would now create a pull request, which is a request to Brenton to merge it into main. Let's not do that because this is literal garbage. He does not need to review this and close it. I got off topic because I was talking about ways that you could use this on yourself. So you could roll back changes one after another without losing them because they still would all be stored on GitHub. All of your versions and all of your reapplications would still be stored until you come back to a point where your intro has changed. Then you can make the next commit, where your intro still works. Then you can make the next commit, figure out what has caused it to not work since then, and after you fix that, reapply all of your changes. So that's a great bug fixing. Or maybe you made an area, but you're entirely unhappy with it, and now it's easier to revert all of your changes rather than to delete it manually in Godot. In any case, this is a very powerful versioning software, and even for individuals' use, it can be quite useful. actually, even if you're like editing your novel or something like this, seeing exactly what changes have been made between edits in the document can be terribly, terribly useful. And if you are making a project with other people, the concept of main and branches is incredibly useful. So I'm introducing you to a bit more than you need to fetch the GitHub yourself, so that if you ever end up in the, programming or coding professionally, you have a bit of background of how to get into GitHub. I've only covered extreme basics here, and I have covered them very exhaustively because some people have had a great deal of difficulty understanding GitHub. But I am barely scratching the surface of what this software is capable of. So here is your long and rambly introduction to Godot.